Hello and welcome to my 1 hour beginner AI learning masterclass. In this video we're going to cover all the basics of enemy AI that you need, such as behavior trees. What are they? What do they do? How can you use them to drive enemy behavior, including using tasks? And also we're going to look at how you can make animation driven attack systems. So we're going to look at how can we make this enemy chase the player continuously and punch them when they get to you. It's going to keep chasing us, gets to us, punch us, we run away, it follows us. It's quite basic, but we're really going to explain and get into all the details of how it works, why it works, and why these things are important. If you want the project files to this, you can get them on my Patreon for $5 a month, along with all my other project files, such as Fortnite building, editing, resource harvesting systems, inventory systems, building systems, climbing systems, loads of different projects. You can get all of them $5 a month. Apart from that, let's get straight into it. Let's get in. You can follow this along step by step. I'll show you everything you need to do, how to make these systems. Okay, so the first thing we're going to do is create our enemy AI that can run around and chase the player. We're going to do this from blueprints to start with. Then we're going to move it over to the behavior tree. So let's start. Let's go to content, draw, create a new blueprint class, make it a character. I'm just going to call it AI underscore character. We'll open it up and we will give it the same mesh as the default character, and we'll just give it the unarmed animation, just so there's a bit of animation. -88 on the location. If you put -90, it's fine, but it doesn't. 88 is more accurate for the bottom of the feet. And for rotation, -90 on the Z, so it's facing the direction of the arrow. Compile that, save that. Then what we need to do is create an AI controller. Now the AI controller is sort of like the brain of the AI character. That's where we're going to run the logic from, and it's like you have your player and you have your player controller. Here you have your AI and your AI controller. Technically you don't need one, but as you'll see later when we start adding senses to the AI, it's a lot more useful to have an AI controller because it gives you extra features. So by default you always want to have an AI controller, so you have more control over the AI. So just call it AIC underscore enemy AI, or whatever you want really. And this is a very important step. You go back to your AI character, make sure you're on class defaults and search for AI. Then scroll down to pawn and look for auto possess AI, set that to place in world or spawned, and for the AI controller class set that to AIC underscore enemy AI, or whatever you just created. What this means is auto possess AI means every time it's placed in the world or spawned, the controller will still act on it. So for example, if I'm here and I go to the content draw and I place the AI into the world right now, and I start the game, this AI is classed as being spawned into the world, or sorry, placed in the world. It's not been spawned, it's been placed into the world. So if we have this setting on just place in world, then now if we started the game, it would be possessed by the controller. But if we had this on just spawned, then this wouldn't. If we started the game, you won't see anything now because we haven't set any logic. But here, this AI hasn't been controlled by the controller. So if we had a bunch of movement logic, it wouldn't do anything. And it's the same thing. Imagine you have like an AI spawner, right? You want to have waves of enemies coming at you and then get spawned over time. If you spawn an enemy into the world during game time, then it's classed as spawned, not placed into the world. So to make sure your enemies controlled in all situations, you have placed in world or spawned. Nice, compile, save. Now the next little bit of default setup we have to do, which is I guess the equivalent of boilerplate code, and boilerplate code is just like code you always have to write just because it's just super important. We need a nav mesh bounds volume, and a nav mesh bounds volume is a volume that you add. So if you click on the quick add to the project, go to volumes and go to nav mesh bounds volume, it's a volume within which enemy AI can calculate things, can do calculations, can check the ground. Without a nav mesh bounds volume, your AI can't like see the world. It's sort of the way for the AI to see the world, see things around them, and just detect things. so you need it, otherwise your enemy just won't run. A really common mistake is that people won't add dynamic bounds volume and they're like, why isn't my AI moving? It's because they haven't set the positions within the AI can do calculations. So just make sure it covers the entire map. Like you can see this cube, I've put 25, 25 and 5 on the scale. Now it covers the map. To check where it's going, you can press P on your keyboard and you see how the ground's changed color. All the green is the places that can be calculated. These little areas here on the side, they just get cut off. There's nothing I can do about that, but all over here, now the AI can essentially see things and that's where they can go to. Press P to get rid of that. So we're going to go to AI character, go to the event graph, and we could call this on event begin play. But I've got a question for you. If we set all of our chase logic on event begin play, but our enemy spawns into the world 5 seconds after begin play, then would they still do that? The answer is no. If you had, I don't know, just a print string on begin play, but you've set like a spawner so your enemy spawns in 5 seconds after begin play, you're not actually ever going to see this because they missed that begin play. So the best thing to do is to, instead of say begin play, say event on possess. Ooh, just catching up here. Event on, well, it should be on possess. Yes. That is exactly right, and this is a good example of what the AI controllers are really useful for, because we are in the AI character, we need to go to the enemy AI. Here we have the event possess, and that's why it's super important to have the controller, because it gives you access to extra functions that you wouldn't have otherwise had, like the event on possess. And this just means whenever the enemy is spawned into the world, where you know, it might have been placed before you've started, or it might have been spawned in after the game started, but whenever the enemy is sort of come to life, this event gets fired. So it's like the begin play relative to the character. So on event possess, this is just good practice. We're going to promote this possessed pawn to a variable, and this possessed pawn is just this enemy, right? It's the instance of the enemy you're using. As soon as that spawn into the world, what we want to do is we want to say get actor of class, and we are going to select BP underscore third person character. Now this just means, you're pretty simple, right? We're finding this actor, which is us, we're the third person character. Now we're going to put a little delay in between, because in my testing I have found that sometimes if you try and run this get actor of class straight away, it doesn't actually work, because, you know, maybe things haven't loaded properly, maybe the actor isn't spawned into the world yet. So we'll just do a little delay of 0.2 seconds to make sure the actor's spawned in. And then after this, we're going to promote this to a variable called it player. Now we have a reference to the player character, and now we can create our chase function. So I'm going to go down here, create a custom event, and I'm going to call it chase player. We could technically just run this logic on the end, but it's just a lot cleaner, a lot better practice to make it in a custom event by itself. And we can simply run the AI move to function called AI move to. This pawn here, it's not what we're chasing, it's the pawn that's being controlled. And fortunately for us, we have that, because when we had event on possess, we promoted the possessed pawn to a variable. We've got it here, possessed pawn. There we go. Now we know which thing is being moved. The destination, you don't have to input both of them. If you're putting in either the destination or the target actor, that's good enough. So we can just put in the player right there. And the acceptance radius is how close you have to be to either the target actor or the target destination to trigger the on success event. So, you know, stop chasing. 5.0 here is just equivalent to 5 centimeters. It's very close. So it is basically touching. How it is here, it's basically touching. Stop and overlap's fine. We don't need to worry about that. Now on success or on fail. So on success is if we've reached a player. On fail, technically could maybe trigger if it's chasing the player and then the player moves to somewhere where it can't reach, but usually this will fire if something's broken. So we're going to do a print string, and I'm just going to say something's broken. F9 to add a breakpoint, which basically means when this node fires, we're going to instantly be notified and it's going to bring us to this page, so we're not going to miss that it's happened. On success, so we have got to the player, we're going to do a delay of 1 second. You don't need this, you could just run it straight away, but I think a delay makes it more accentuated, you can see better what's going on. Then we're going to recall the event, chase player. To close the loop, now we're going to go to the player, wait a second, then chase again. So now on event possess, we do all this logic, get the player, we're going to call this event initially, chase player. Now if we compile, save, go into the world, we've got the Navamish bounds volume, we've got him, he is definitely possessed. I just like to make sure. AI sim_AI. Now when we play it, he's running to us, he's going to chase us. His default speed should be 600, I think, which is the same as what ours is by default, so he never should catch us if we let him. But if he gets to us, he stops, and then after a second he chases us again. That's cool. That's the first step. We've got our enemy AI set up where he's just going to run around the map, but that's not super useful. It's not much, and you don't typically do it like this. I prefer, at least, you can do with state trees, but I prefer doing it with behavior trees. I do have another video on state trees, like a full setup for what you can do to make, patrol states, chasing states, like run away and hide, like checking out, like querying states. I've got a video on that, I'll put links in the description. But other than that, we're gonna look how can we do this and more with behavior trees. Okay, now we're going to move everything over to our behavior tree. So go to content browser, right click, search for behavior tree. I'm just going to call this bt_enemy. And then we're going to need a blackboard. So just search for blackboard. I'm going to call this bbd_enemy. So before we actually start creating the logic, I'll just take a bit of time to explain what these things are. So first of all, your behavior tree is literally a tree, right? You have your root and then you drag down and you can organize what's going to happen in what order. And the idea is it's like a tree, and it goes from left to right, and it just says we're going to execute these things in this order, and you can have different branches that check different conditions of whether things are going to run or not. So it might look like this. You have a selector, you might have a sequence here, you might have another sequence here. And then, you come to your root, you go to the selector is going to go from left to right, always left to right, and it's going to check, can we run this sequence? If we can run this sequence, and then when the sequence is completed, the selector's completed, then we run again. Because the selector is particular because it will complete once one of its children succeeds. And what that means is as soon as this selector succeeds, it all restarts. The whole thing restarts. If this sequence succeeds, we never see this sequence. And that's kind of how you choose what to run, what not to run. Imagine you're having a chase player state and an attack player state. You can go to this sequence, you can check what state you're in, and you can say, are we in chase sequence? If you are in chase sequence, run the chase sequence. Then you don't want to do attack sequence if you're not in attack sequence. So then you just complete this sequence, go to selector, the selector completes, everything restarts. If this fails, you go to this sequence, and then you run everything. If everything fails, then everything fails, but because this is the only selector, then that would fail, obviously. You'll see how it goes as we add tasks. It's not that complicated, it takes a bit of getting used to, but I prefer this a lot to state trees, which is a way of organizing things by state. I think this is just more intuitive, that's my personal opinion. But the blackboard, what the blackboard does is that contains a bunch of variables and information that you can use in the behavior tree, and they're always linked together. You always need one to have the other. So imagine we come here, we go to this sequence, right? This is our chase sequence. And imagine we have a task. I'll talk about tasks in just a second. We have a task called chase player. And we want to input to this task the player that we're chasing. We can get that variable from the blackboard. The blackboard will contain all these variables, and we can set the variable in the blackboard inside this enemy AI. So what might happen is we go to the enemy AI, we get the player, and then we can get the blackboard by literally just saying get blackboard. It automatically gets the right one. And then we can say, just for example, set value as object. An actor is also an object. It's like the child class of what an object is. So object works for actors as well. And then, you know, we'd put we'd put the player in here. We'd say which key it is. We haven't created a key yet. But now once we've set this blackboard now knows of a player. If we'd have made a variable, then we can go to the behavior tree, we go to the chase task, which would be down here somewhere. We'd input that variable, then in there we could have move to logic, which is based on that. And that's kind of how it works. It's just you break down big tasks into lots of little tasks. Your overall enemy behavior, it gets broken down into sometimes tens and hundreds, maybe if you had a really complex enemy, of different things to do. So let's get started. This is all right, really. We can just go selected to chase sequence, and in the blackboard we're going to make a new key of type object. It is going to be an actor, but there's no actor key, it's just an object key. And we'll call this target because it's going to be the target we're running to. That's all we need, really. We could set the default value, but I don't like setting it here. I find it a little bit flaky, so I'm just going to press F2 on the target name, Control C to copy that name, because we're going to need the exact name to reference it here. I'll just delete this so we can all get back to the same starting point, right? We'll leave this chase play sequence for now, but get rid of the call at the end, so we're not calling it anymore. We're going to right click, search for get blackboard, which is automatically going to get the blackboard that we're using. We're going to say set value as object. It'll load, my keyboard's just bugging. Set value as object, plug that in, and then the key name, we're going to promote this to a variable because otherwise we can't properly set it, and we're going to say attack target key name, compile and save so we can give it a default variable. In here we're going to Control V to copy in that target. I mean, it's just a word target, right? So you could have just remembered it, but I think if you have a bigger name, it's very important to Control C, because if I'd have, for example, said target like this without a capital T, that is not the same. It is case sensitive. That wouldn't work anymore. We're not sending the variable to the right place. So to make sure we're referencing the right key, we're going to copy and paste to be extra sure. The object value is the player that we set as a variable already. So now when this runs, we're going to set this variable in our blackboard target to our player that we want to chase. And now we've passed over a bit of data to the behavior tree, because anything that's in the blackboard can be used by the behavior tree. By default, it's there. You can see down here, the bottom right, we've got the self actor and the target. We have those variables always ready to use. That's great. But there's one thing really though, one really important thing that we need to do, and that's run the behavior tree, which fortunately can be done through run behavior tree. And we can decide what behavior tree to use. We can come to here and we can just say BT enemy. Now, if you had a more complex enemy system, what I like to do is on the enemy itself, so on the AI character, you can make a variable. You can call it behavior tree of type behavior tree. You can do that. Then we can set the value to BT enemy, and then in the enemy here we can cast this to AI underscore character, and then we can say get behavior tree, and this would be the behavior tree that we set on here. Now we're not going to do this for this example because we've only got one and it's quite a simple system, but imagine if you had a main enemy and then you had like 5 children enemies that all derive from it. So you might have like a main enemy with all the functionality, then you might have elemental types of that enemy. You want to have a fire one, which is mostly the same but just has a little bit different. You can make children types and they'd all have their own individual behavior tree, and because you're setting it on a variable, if you change the behavior tree here, it automatically gets changed here. So that's, you know, really it's a better way of doing it. It's simpler here because we just have one, but that's just something you can think about if you really want to get into a larger enemy system chain. I'll just delete this variable because we don't need it. And then back here we're running the behavior tree. This boolean value just means did it work. You know, imagine we're trying to, I don't know, run a tree that doesn't exist or that doesn't work or something breaks. We want to know, did this not work? So I'm just going to do a print and say behavior tree didn't run. I'm going to put an F9 breakpoint on there. Just press F9 and it adds breakpoint, so we'll instantly get notified if that fails because that is super important. You want to know. So what we've done now, just to recap, we're possessing the AI. We're setting this to a variable so we know which AI we've just possessed. We're waiting 0.2 seconds because if you don't, sometimes things haven't quite loaded yet. Then we're finding the BP third person character, which is us. We're finding the player, we're promoting it to a variable, so we've got a reference to our target. Then we're running the behavior tree and we're passing that player variable through to the blackboard, so the behavior tree now knows which player we're chasing. Great, so we're going to come to the blackboard. We've got the root, the selector, the chase. I'll recap what they do once we've built in a task, the selector and the sequence, but they kind of are quite simple in the idea. So in the top here we've got new blackboard, new task, new decorator, new service. The new blackboard we don't need because we've got a blackboard. The new task is a way of basically setting functions that run inside the behavior tree. So you know, in your characters you can go in here, you don't actually do this, I'm just testing, but you know, you press create function and you can say, I don't know, this is a function, right? You've just made a new function, and then you do a bunch of logic. When you create a new task, you're sort of just creating a new function for the behavior tree. Now it's not exactly a function because you can create more functions inside it. It's almost like a new event graph, really, and that's how you get all your logic through. But you can also reference 2 other event graphs, which we will do later when we add a punching mechanic for the enemy. We're going to press create new task. I'm going to create a folder, new folder, just call it tasks. Go inside there, call it BTT underscore chase player. It's good practice to call it BTT. You can obviously call it whatever you want, but I find personally it's really good to follow the standard naming. Like when you first start, you might think, what's the point? And you just call it whatever. But you know, calling things like BP underscore, BTT underscore, BT underscore for behavior tree, or BTT for behavior tree task, it's very important to make your code readable. Not just for you now, but for other people. And you might think no one's ever going to read the code, and that might be true, but if you come back to your project in 6 months, then you want to be able to read it as well. You'll have forgotten everything, so you need to be able to read it as well. So inside this task, it looks like an event graph. It's not too different, but I think the main thing really is, you go to functions over here, you got 6 overrideable functions, you click on override. The thing is, the first time you see this, it looks a bit confusing because you're looking around and there's loads of things to click on. The only thing you need to remember here is receive execute AI. That's it. You never use the other ones. Technically you could, but like, let's be real, 99% of the time you only use this one. So don't even think about the other ones. You just click functions, override, receive, execute AI. That's it. And this basically means when this has been called, which we can call by just dragging off chase and saying btt underscore chase player, as soon as our logic gets to here, it goes to root, to selector, to chase. As soon as it gets to base player, this is fired in the base player. In the chase player function or task, really. Now we know in our behavior tree that we've got our target, right? We have this information in the behavior tree, so we need to pass this target variable from the behavior tree to the chase player task. I just want you to think about that 5 seconds. Like, how would you do that? How would you get that variable across? It's important to think about this because it's thinking when you really learn stuff, even if you think wrong. Okay, the way I'm going to do it is I'm going to make a variable. We're going to call it attack target, and it's going to be of type blackboard key selector. This basically means it can be a blackboard key. I pressed instance editable and expose and spawn because what that does is it means we can see it from this task. Otherwise we can't. If I just take these off and we go back, now you can't see anything, you can't see any of the variables, but we're exposing the variable of this task to the behavior tree so the behavior tree can set it. So we've got the attack target variable, we're going to set it to target because now we're going from the behavior tree to the task with that variable of target. That's nice. Now in here we know what the target is, so if we bring this in, get attack target, we can say get value as actor. We don't have to say object. Now we can get it as an actor, and this is our target. It's the player we set all the way from the AI, and we've just got it. There are, different ways to do this with casting and interfaces, but this is the standard way to do it, really. This is how you do it. And similarly, how in our AI controller we use the move to function, that's what we're going to do here. We're going to say AI move to the pawn, which remember is the thing that's getting moved, is going to be the controlled pawn. If you double click on the line, you can add what's called a reroute node. Not a break node, a reroute node. And that just, you can drag the reroute nodes to better organize where the lines go. And here we're going to drag into the target actor. Again, remember the acceptance radius is how close you have to be. 5 is 5 centimeters, so basically touching. And then on success and on fail, we are going to do something called finish execute. Now, what finish execute does is it allows your task to end. It doesn't mean that like what you've done is true or has worked. It just means that if we had another task here, we'll just add one of the basic ones, make noise, we're going to stay in the chase player. We're going to stay here until this finish execute has gone off with either success or false, and we'll talk about what that means in a sec. But if we never add that, if we get rid of this node and we never do this, we're going to move to the player and we're just going to stop because we haven't told our behavior tree to move out of this task. So we're ending the task, we move out of it with finish task. Finish execute, not finish task, finish execute. On success, we're going to put success. On fail, we're also going to put success, but I'm just going to add a break node so I can see what happens. You see, success and fail doesn't mean what you've done has failed or succeeded. What it means is, should we go to the next task? That means if it succeeded, right? So we've succeeded on success, we go success. That means we move to the next task. If it's failed, then we just fail this task. That means the sequence fails, which means the selectors fails, which means everything resets, the whole logic resets. Now, it's really up to you whether you want this to be success or false. For now, I'm going to leave it as success because, well, it's not going to make any difference. To be honest, we've got one thing, right? As soon as this succeeds, everything's going to reset. But just keep in mind, if you want your logic to reset when your enemy has failed to move to them, which means something's broken or it just hasn't reached them because, I don't know, your player's moved out of the bounds of the area where the enemy can go, maybe, it's completely up to you. For now, it's success, but keep in mind, this just means, are we going to move on to the next task? Are we going to fail and, fail the sequence? And failing the sequence means that it goes from left to right. So if we have a bunch of tasks here, it's always going to go left to right in this order. And as soon as one of these fails, we stop moving to the next one, and the sequence is, said to fail. And then if the sequence fails, the selector, well, in this instance it would fail because there's only one of them, but if we read here, from left to right will stop executing if one of their children succeeds. If it succeeds, the selector succeeds. If the selected children fail, the selector fails. And if this selector fails, nothing's broken, it just means you reset. You go back to root and you reset everything. So here, we go in here, we move to our player. We've got that information. I'm just double checking everything for myself here. We've got the target selected incorrectly. The AIC enemy, we are running the behavior tree, passing the value over. That we don't need anymore. I'll leave it for now, just to leave it actually. But I'll comment it. So if you highlight it and comment it, you can say this is not in use. Compile, save, run, and now we're being chased. So, oh yes, this was triggered, right? This fail was triggered. This doesn't mean something's broke. If we go back into the level here, looks a bit weird, nothing's broke. What's happened is I've jumped off the side, and the enemy can't jump. The enemy can only walk on the floor where the green is. There's no green in the air. The enemy can't chase me through the air. So there, the enemy's connection has been broken. For that brief second, the enemy cannot think, how am I going to get to the player? Because it can't. When I'm in the air, the enemy can't get me. But what's going to happen is as soon as I hit the ground, the enemy's going to recalculate. It's going to find a new route to get to me, and then it's going to go again. So I've failed the move to there, but nothing's broken. It's still working. And as soon as the thing runs again, it's going to be fine. Where's my mouse gone? Oh, my mouse has disappeared off the screen. I'll just exit there. I had to exit that, but I'll show you again. So I'm just going to run off the side. Oh, I didn't fail that time. Is it still on the reroute node? Break node, sorry. Yes, it is. I don't know why that's not failing. Okay, so he's been a bit smarter this time. But it was the same thing. That's definitely what happened. He would have chased me. Ooh, stuck on him. He would have chased me as soon as we got down. I just couldn't unpause it because my mouse had just disappeared for some reason. See if I can get... Yeah, there we go, there we go. So yeah, we're in the air. He can't get us. There's no way of doing it. So we've hit the break node. But as soon as you press that... Okay, it's going to do it again. Let's just take that off. We're going to hit the ground. He's going to recalculate and he's going to chase us again. So that's expected. That's normal. He's chasing us. Now, what we're going to do is we're going to add some logic to say when he gets to us, when he's reached us, we want him to punch us. We want him to punch us. Now, the common way of adding an attack, and the way I usually do it, is through animations. It's animation-driven attacks, and that basically means we're just going to play an animation, and at various points in this animation, we can trigger logic. So we go to chase player. If he gets to us, we've succeeded. Now, if he fails, we're going to reset because we're going to set it to false. We don't want him to move on to this next part of logic if he's failed. We want him to go again because we're going to make another task, press new task, blueprint base, and we're going to say BTT_attack player. for now, I'll just leave that empty so we can add this in btt underscore. Oh, I don't know why that's not there. Now it is. btt underscore attack player, right? So if this succeeds, if chase player succeeds, if we get to the player, we're going to fire this attack player logic. We'll change this to chase and attack. Why not? That sounds good. Chase and attack. Now this attack player logic is going to fire, and if this fails, and that doesn't just mean something's broken like we just demonstrated. If you jump in the air, it might briefly say you can't get to you. It will just reset, right? So when we jumped in the air then, if that still was on success, we would have moved on to the next function, which would be attack, and then he would have just done a punch, like randomly, right there where he's standing. And that's not what we want. So, how are we going to make him attack us? What are we actually going to do? Before we jump into it, I'll explain the idea. I'll just take a 30 seconds just to say what we're going to do. What I want to do is, when we get to this function, we know we're at the player, right? We know we're at the player because we're in a radius of 5, which is why that's finished. So here we're at the player. Now, I'm going to fire an animation. I'm literally just going to say, play this animation. We're going to play an animation, which is going to be a punch animation. And we're going to go into the animation, and we're going to say, when we hit this frame, which will be when his arm's fully extended, we're going to do a sphere trace around his fist. So we're going to detect a zone around his fist, and if there is a player within that zone around the fist, then we're going to do some damage to the player, right? And that's going to hurt the player, and that's the idea. So I have got an animation already. I brought it in before this project started, this hook punch 1 underscore UE. I just got it off Mixamo. I retargeted it from Mixamo. I'm not going to go over how to do that because that's kind of a separate thing. If you want, I mean, you don't need the animation, but if you want to have this exact animation, you can get the project files on my Patreon. Everything's on there with all my other projects. So if you want the animation, you can get it from there. Otherwise, you can bring in any animation you have, anything off Mixamo. It's quite easy to retarget something. Literally just go on YouTube and search UE5 to Mixamo retargeter. You'll see a 5-minute video, but that's not what I want to cover. So we have our animation. You can use any animation. You're going to right click on it, and you're going to say create, find the create one, and you're going to say anim montage. You're going to go an underscore punch. And what an anim montage does, the difference is you can add things to the animation track. And for us, that's really important. We're going to add a notify. So here, we're going to move this until he's at the end of the punch. I think here is about good to say the end of the punch. Yeah. Or we could do it maybe in between 2 frames. Maybe instead of just saying at the punch on 1 frame, maybe we could say in between this frame, add notify, montage notify. We can say, give it a notify name of start. So adding a notify of start, and we're going to go to the end of the punch. I'll just say it's there. We're going to add another notify, montage notify, and we're going to call it end. And what this does is when this start notifies fires, we'll get an event on it, and when this end notify fires, we get another event. I'll show you where that is in just a sec. So when this fires and then this fires, in between these 2 frames, we'll have like a running event. We'll be able to have logic firing in between these 2 notifies. And the way we're going to do that is in our character, not our AI controller. In our character, we're going to make a custom event. Call it punch. So we can fire this. We can go to our AI character from this task. So we can go to the task, then call to our character. So we can do it from here, which is a lot easier because to play this animation, we're going to need some events such as the skeleton we're playing on. And that's a lot easier to just keep it all over here. So off the punch, we're going to say play anim montage. Yes, play. Oh, maybe it's play animation. Wait, there's 2. Let me just check. Play animation. Nope, it isn't. It is not that one. Play and it. Oh no, play montage. Yes, play montage. There's a bunch of nodes for playing the montage, but I wanted to use this specific one because we can input the skeletal mesh component, which we have from the mesh. We're going to input the montage to play, which is the punch. Play rate, we don't have to touch any of these extra settings. Never need to. Not never, but you don't. Why we want to change the play rate, right? So this is the important part. On notify name, we can say switch on name. We're going to put that on there, on completed. Actually, no. On notify begin. And what this means is as soon as this notify begins, this start notify begins, here it's going to switch on this case that we're going to make a case and call it start. It has to be case sensitive, has to be the same. Is that? So, yes, so there we used a capital. We have to use a capital again. So we've done a switch. We've added a pin up here. We've called it start. And we can add another one called end. And we can add logic. I'm just going to uncheck that has default pin. We don't need it. We can add logic in between these two pins now. So I'm going to make another custom event. Just wait for it to load. Called, I don't know, sphere trace around fist. And what this sphere trace is going to be, we're going to make a timer that that begins on start and ends on end. And whilst this timer's running, every, like, I don't know, 0.2 seconds, we're going to call this function, which is going to do a sphere trace around the fist, and it's going to apply some damage if it hits someone. So on start, we're going to set timer by event. We're going to make, nope. Okay, we'll just say custom event. Well, actually, we don't even need to do that. We can just drag this over here. Yeah, we can connect it. Oh, wait, no. There's a node I wanted to show you. It's create event. Yes, create event. And then you don't have to physically drag it over. It just looks a bit cleaner. So if you drag off this event and say create event, you can select the function, which is called sphere trace around fist. And now we can put in a time, looping, maximums per frame. Maximums per frame, we're not going to run it that much. Every time we're going to say 0.2 seconds, I'm going to put on looping. So after this begins, every 0.2 seconds, we're going to fire this. This handle is just a reference to the timer. And it's how we're going to be able to disable the timer after it started. So we'll get that. All we need to do is set it. Then on end, we get the timer handle and we say clear and invalidate timer by handle. So this means when the start happens, we're triggering this event, which is like every 0.2 seconds we do this. And then when we hit the end pin, which is here, when we hit the end pin after like what is that, 13, 14 frames, it's going to end. Right, so we're doing this timer in between. On this, we are going to say sphere trace by channel. Sphere trace by channel. Now, you might be thinking, like, where's the start and end point? Like, how do we know where the fist is? And what I like to do is go to the mesh, add an arrow to, like, as a child of the mesh. So click on the mesh and then click add arrow. F2 just to hand arrow. And then, oh, is it the left or right hand? Let's check the animation. Right hand, that's punching. So we need the right hand. Go to our character, hand arrow, parent socket. Because it's a child of the mesh, we can look at all the sockets on there. We got all the bones and stuff. So we can search for the bone that is like hand underscore R, right hand. So now this arrow is attached to his right hand. And that means we can get the position of the start of the arrow, where we should say sure, or is it hidden maybe, or visible? Yeah, okay, so take off visible, right, we don't want to see it. But inside our logic, we can get this arrow, we can say get world location, and this is going to be the start of the arrow and not the end. So start there, radius I think 15. We'll put on the draw debug type for 1 frame so we can see it. Actually no, for duration. Actors to ignore, we're going to say make, which is going to make the array. Input, we're going to say self, because we don't want to detect ourself. Check if we've hit something with a branch, and then if we've hit something, we can break the out hit to get all the information about the thing we hit. We can go to the hit actor. Now, how are we going to check if this is the hit actor? You could say cast to BP underscore third person character. Don't do this. I'm just showing you an example. Don't do this, right? You don't need to. You could do this, and you could check, has the cast succeeded or has it failed? If the cast fails, it just means you haven't had it. It's like a branch check. Is it this or is it not? And then you could say like do damage or something, right? But instead of doing that, what you can do, which is a little bit more efficient, is we can go to our character and we can give them a tag. So if you press Control P on your keyboard, Control P, it opens up this asset searcher thing. I mean, you could go to your content drawer, right? But it's a lot quicker to do this. Control P, and you can just search BP underscore third person character. It's a lot quicker just to find it here. You could go to your content drawer, and then here we can go to our class defaults, details search. We're going to search for tag. Go to tag, and we're going to just give it a tag called player. And this basically means when we get like an actor from anything, we can check actor has tag, and we can input that player tag, and then we're just checking if it's got that tag or not. Now you might be thinking that, why would you do that? You just had to spend more time doing it. It takes longer to set up, but it's a lot less resource heavy, because instead of loading the entirety of the player, instead of having to load all of the player class just to check if it exists or not, you can just check if it has one tag or not, and that's a lot quicker. So actor has tag, and then what do we want to do when it has the tag? We could just say for now, just for testing, we'll say print hit player. Right, we're gonna say hit player. We'll come back and we'll add a punch thing later. But just so we can move on and see if it works, we'll just leave it at a print for now. I'll make it last a little bit longer. I'll make the duration 5 seconds. And then if we go back to our task, attack player, what was the function? Just think about it. What was the function we needed? It was this one, receive execute AI. We've got our controlled pawn. We can cast to AIC underscore, no, it wasn't AIC, it was AI character. Yep, cast to AI character, and here we can call punch. But I hear you say, how are we going to end the task? You said finish execute, right? But if we call finish execute as soon as we've called punch, then the frame that this is called, we're going to move on to the next thing. We're going to end. So we're not actually going to do any of the punch trace, because we're not going to have time to, because as soon as it's fired, we're going to end. So how can we make sure that we only move on to the next task? We only call this finish execute when we have finished a punch. That is the question we need to solve. And fortunately, there's a very easy solution, which is called event dispatchers. An event dispatcher is like saying this is a generic call, right? We're going to fire this event. We're going to fire this. Anyone who's listening, anyone who's watching out for this event to be fired will be notified, and then they can do something. The analogy I really like is like, it's like a microwave. You set a microwave, it goes off when you want, you can set it to whatever you want, and it's like the ding, right? As soon as the ding happens, someone's going to hear it, then they're going to decide what to do. You can have as many people listening for that ding or not listening, but we're going to set this, we're going to set an event dispatcher here to fire when it ends. So we're going to create an event dispatcher, call it punch end, We're going to drag it over here. We're going to, no, we don't need to bind it. We're going to call it. So we're calling, this is like the ding of the microwave that just popped, right? So we're doing all of this and the microwave has just gone off. The pops just happened, right? The ping of the microwave just happened on the punch end. Then in our attack player, we're going to say we're going to listen for that. So we're going to say assign punch end. And what that does is it's going to give us a bind and it's going to give us a function. So this bind just means this function, this bind function, not this one yet, just this, we could take this off and it'd still work. This is going to get called as soon as that ding of the microwave goes off. Okay, there's an error because I haven't assigned it, but don't worry about that error. I know everyone says that, right? And that's not, you don't want to hear that. Don't worry about the error, but it's fine for now because if we put this in, it's going to work. Yeah. But this is the ding of the microwave that's just going to go off. We're only going to end this. We're only going to say finish execute when, oh, that's not it. Finish execute. We're only going to say finish execute when we have heard that the punch has ended. So this basically means do the punch, then bind to event punch end, which means wait until you are told that punch has ended, and you tell that punch has ended when the end happens, and this end happens when this notify is called right here. That's the chain of events. So then we go here, finish execute, and then it's back to here, and then everything's all good. So if we play, going to get to us, he's going to throw a punch, and you can see the sphere traces around his hand during those events. Oh, I'll just look from this view, it's a bit easier. During these events, he's throwing the punch, and you can see that he's attacking us. If we run away, he's going to stop punching, he's going to move back to chasing. He's going to keep chasing us, get to us, punch. Now, to finish this off, the last thing we're going to do is just add a bit of health. We're going to give some health to the character, and we're going to make it so that when the enemy punches the character, he does damage. First of all, Control Shift S to save all, very important. And then we'll give the player some health, the enemy an ability to remove some health, and then maybe like the character is just destroyed when you lose all your health. All right, cool. So first of all, I'm just going to close all these tabs just because we've got a lot of stuff open. And we don't want to start clean again. So I'm going to press Control P to open up that content searcher. Again, you can do it from the content browser, but this just looks more professional, right? Let's be honest. BP underscore third person character. We're going to give them a variable called max health of type float. Oh, not integer, of type float, and current health. Again, of type float. I set the first one to float before making the second one, because then it's automatically going to make this float as well. You might notice that, might not, but it's just a little bit quicker. Well, not quicker now said, but max health. At default, we're going to say that's 100. At default, current health also is going to be 100. I don't know what happened there. And we're going to make a function called remove health, and all this is going to do is going to take an input of damage, right? So we're going to have a function, we're going to tell this function how much damage has been dealt, and it's going to go to the max health. It's going to set the max health to, actually no, it's not max health. What am I doing? It's current health. We're going to set the current health, that's more like it, to current health subtracted by damage. Right, so we're going to get the damage. We don't know how we're setting the damage yet, but this is just the function to deal with it. So the function's been passed through. We're going to reduce our current health by the damage and then update our current health to that. Now we're going to do a less than or equals, less than or equals 0. I'm going to do a branch. So we can check, is our health now after subtracting health, is it 0 or is it less? Because if it is less, we want to say dead, right? Death. Well, I won't do a print. We'll just say destroy actor. You could do like a whole death screen restart if you wanted, but I want to wrap this up within an hour, so we'll just keep it nice and sharp. Destroy actor. If not, you don't need to do anything because you've already done the logic for subtracting the health. We'll print the health as well, actually, just so we've got a visual cue of what's going on. We'll say print just so we get it on the screen. There we go. Now, there is indeed a callable function for damage being taken. You can say event any damage, and this is kind of like the event dispatcher we had before, actually. The event damage, it's like it's listening for any damage. It is exactly like the dispatcher we had before behind the scenes. It's waiting to be told that damage has been dealt, and it will fire over some of these variables. So all we need to do is just plug in this remove health function, plug in the damage, and we're done. You can also check like who hit you, who did damage, what type is the damage. We're just going to remove some health, nice and easy. Yeah, so now we just need to call this, like with the event dispatcher we used before. We called it in the task to say we're listening for it, and we had to, like the ding of the microwave, we had to say this is where it happens, right? This is where we are going to do the damage. To do that, we're going to go back to the enemy, the AI character, and on our punch, in this sphere trace around fist thing, instead of just saying hit player, what we're going to do is we are going to say apply damage, and I'm going to input, let's just say 25 damage. Well, we'll say 50 just so it goes a bit quicker. Event instigate damage cause itself. We don't need to do this because we don't do anything, but you know, might as well, right? We've done the damage. So as soon as this happens, we're going to apply damage. The player's going to receive it, remove health. Cool, cool, cool. And we're going to be removed if it's gone. Okay. That is not good. Wait, is the sphere not big enough maybe? Let's just make the radius a little bit bigger. 30. I do actually have an idea why this isn't working. Yeah, okay, so if we change this from visibility to camera, if this works, I'll explain exactly why. Yeah, okay, yeah, so it punched us. It went twice because we have it on a loop. I'll take this down to 10 damage. I'll just show you again, and then I will explain why that made a difference in just a second. So he's going to punch us. Right, you can see in the top left hand corner, our health is going down. No, we're nearly dead. We run away. It comes, it punches us, hits us, and then blah, blah. Okay. So the reason that made a difference is because our third person character, if we go to the mesh and if we search for collision here, we can see under the collision presets that visibility is set to ignore and that camera is set to block. That means if the camera hits it, it'll know, like it detects like the camera traces, but it doesn't detect visibility traces. So on the AI character, when we do a trace and set it to visibility as a visibility trace, it is ignored on this capsule. If I set this to block, I'm not going to do it, I don't need to, but if I set that to block, it would then work because it's blocking, it's hitting, it's noticing the visibility traces, but for now it's just ignore. But because the camera is being blocked, the camera traces is being blocked, we set that to camera, compile, and then now it works again. So that's why that made a difference. So yeah, that is the AI. That is how AI works. That is how you set up an AI controller. That is how you set up functions and tasks and interfaces them together. It's how you can set up an event dispatcher to, you know, like the ding of a microwave, have things happen, like a simple punch. That, you know, behavior trees and blackboards, very, very important. Again, you can use state trees, and I do have a complete video on state trees that's very in depth. That is a bit more advanced, so if you feel like you're just struggling to get along with this video, that other one might be a bit complicated for you, but if you feel you really understood this video, then the other one might be good to move on to. But I prefer behavior trees, definitely. and this is just the basis of how it works, how you can build blocks together and have behavior fire one after another, you know, have checks happen, like if this was not succeeding, if this was false, we wouldn't get to this one. So that's everything we covered today. I hope that you've learned something from this video, because I think it is basically all you really need to know about enemy AI to get started. You can get all my systems and some models, like I made the Fortnite resource harvesting system, I made a boss fight, I made the climbing from Zelda Breath of the Wild. I've also got like the Fortnite Save the World crafting system, some straight tree stuff. You know, I've got loads of stuff. It's £5 or $5 rather a month, and you get all the systems for $5, including this one that will go up. So if you want to look at these other systems, some of them are actually really good, at least in my opinion. I really like the Fortnite building system. It's like the harvesting, everything. You can see there's another video on my channel. But yeah, thanks for watching.